The second question, for a UI characteristic curve we have just drawn, what it means if US is equal to 0. Obviously, it is such a line. Do you remember in the last lecture what UI characteristic curve of R is? What is the value of alpha to make the characteristic line of the resistor the same as this one? Yes, alpha is equal to 0. It becomes such a line. For resistor, alpha is equal to 0 or R equals 0. This line is the same as this line, where US is equal to 0 for voltage source, right? Yes, just the same. The feature is that the voltage is 0 and the current is determined by the external circuit. So we have a very important conclusion. That zero value resistance is equivalent to zero value voltage source in terms of electrical characteristics. Then let's discuss the ideal independent current source. You may not be familiar with this concept. I will give you more details. Its circuit symbol is a circle with a vertical line in the middle. Then we cannot only put the current symbol outside, but also draw the arrow of the current inside. It's the same. It has two features. It's symmetric with the voltage source. First, it is independent. That is to say, for the current source, the value of its IS and its direction are determined by its manufacturer. It is independent of other elements. If under the condition of DC, it is a constant value and expressed by capital IS. If a sinusoid AC is changing as a sine wave. This is the first point. The second point we discuss the condition when a current source is connected to a resistor. Obviously, the current flowing through it is 1 ampere. We calculate the voltage across the resistor. That is I times R equals R. The voltage across the resistor is also the voltage across the current source. It's equal to R. An important conclusion is that for the independent current source, the voltage is determined by the external circuit. Specific to this example, it is determined by the resistance. Next, it is also similar to the independent voltage source. We draw the UI features curve of the independent DC current source. The current is always capital IS, while the vertical can be any value, so it is such a line. Analogously, we have a question here. That is, if IS equals 0, it is such a line. In the previous discussion of the resistor, we have known that here alpha is equal to 90 degrees. What does that mean? It means that the resistance is infinitive. At this time, the UI curve becomes such a line. We compare this line and that line. Do you have any difference? They have no difference. They are all characterized by the zero value current, but they can both provide all kinds of voltage. What does that mean? It means that open circuit or infinitive value resistance is equivalent to zero value current source in terms of electrical characteristics. It's also very important. Then we discuss the open circuit and the short circuit for the independent source. For the independent current source, we connect the resistor. If it's a short circuit, we draw the circuit here. It doesn't have any problem. The current flows through it, so the current is equal to IS and the voltage is 0 because it is a short current line. If a voltage source connected with a resistor, it is considered to be an open circuit. The circuit becomes this. This also has no problem. it equivalent to the no load condition of the battery. So I is equal to 0 and U is equal to US. Then we ask two troublesome questions. If a current source circuit is open, or a voltage source circuit is short, what will happen? Please revisit the question after completed lecture 10. Next, we discuss the power of the independent sources. This is the independent voltage source. Remember the question I just asked? For the independent voltage source, are current and voltage associated or non-associated? Pay attention to the current flows into it from here. That is to say, for this two-terminal element, they are non-associated when the current flows into the element from the negative terminal. We can calculate the supplied power, that is U times I. We know U is equal to US, so it's equal to US times I. US is its essential feature and I is determined by the external circuit. If you want to calculate the absorbed power, the current should flow in from this side. If the current flows in from here, it is minus I. So the power of absorption is minus U times I, which is also minus US times I. Here we reviewed two kinds of memory methods for the power under the associated reference directions. Analogously, for the current source, they are non-associated reference directions when current flows into the negative terminal, and the supplied power is equal to U times IS, where the absorbed power is equal to minus U times IS. You may have a question here. Why we always set the associated reference directions when we're talking about resistors, but when we were just talking about the voltage sources, it is set as the non-associated reference directions. We will discuss in later lecture about it. Finally, we introduce the model for real sources. For a real voltage source, as we discussed in lecture 1, if it is a battery, we can connect an ideal voltage source and an internal resistor in series to represent the characteristics of the circuit. It is very intuitive. For a real current source, we also can connect an ideal current source and an internal resistor in parallel to express circuit characteristics. This is not very intuitive. I have a question now. For the voltage source, a battery is a very good and intuitive example. But how can we get a current source? How can we find or implement a current source in real life? We will give careful discussion about it in lecture 16. Okay, that's the end of this lecture.